Welcome to VEDHA online classes. VEDHA online classes is providing the live online tuitions for intermediate CBSE, EAMCET, IIT-JEE, BITSAT. If you want the good marks in these exams, then please like and share with your friends and subscribe and activate the bell icon for getting the all notifications from our VEDHA online classes. In this video, I am going to explain the most important LAQs, long answer questions from the matrices. These are very important and little bit they are tricky questions. Okay, so that's why watch the video till end. If 3a is equals to 1 2 2 2 1 minus 2 minus 2 2 minus 1, then show that A inverse is equals to A transpose. Okay. So here in this question, what is given what is given matrix here? So 3a is equals to 1 2 2 2 1 minus 2 minus 2 2 minus 1. This is the 3a value. This is the 3a value. Now from this we can find the value of A. A is equals to 1 by 3. Here 3 is multiplying here. If you take it that side, divides. So 1 by 3 into 1 2 2 2 1 minus 2 and minus 2 2 minus 1 minus 2 2 minus 1. Okay, this is the A matrix. Okay, after that what we have to prove here? What we have to prove? So here we are going to prove A inverse is equals to A transpose. A inverse is equals to A transpose. Okay, this implies I am multiplying by A on both sides. So A into A inverse is equals to A into A transpose. Okay, we know that A into A inverse is equals to I. So I is equals to A into A transpose. Since what is the formula here? A into A transpose is equals to identity matrix it is. So finally, what we are going to prove here, we are going to prove A into A transpose is equals to I, or we can prove A transpose into A is equals to I. Okay, so instead of proving this, we can prove A into A transpose is equals to I also. Both are same. Both are same here. Okay, so now find the A transpose. Find the transpose of A. Now, okay, I am finding the transpose of A. A transpose is equals to that 1 by 3 coefficient as it is I am writing. So the rows we write as a column or columns write as a row. 1 2 2 is a row, writing as a column 1 2 2, and 2 1 minus 2 is a row, writing as a column. Minus 2 2 minus 1 is a row, writing as a column. This is the A transpose. It is A transpose. So now here I am taking the LHS. LHS is equals to A into A transpose. A into A transpose, that is equals to 1 by 3 into what is A matrix here?
1 2 2.
1 2 2. Next
2 1 minus 2.
2 1 minus 2. Next
Minus 2 2 minus 1.
minus 2 2 minus 1. Okay, this is A matrix and A transpose.
1 2 minus 2.
1 2 minus 2.
2 1 2.
Yes.
2 minus 2 minus 1.
Yes. Outside we have the coefficient 1 by 3. Outside coefficient is 1 by 3. This 1 by 3, this 1 by 3, I am writing together in the outside. Okay. So now here this is equals to first matrix 1 by 3 and the second matrix 1 by 3 written outside, and I am multiplying now. Okay. So how do we multiply? We multiply the rows with the columns. Okay. First matrix rows we multiply with the second matrix column. Second matrix columns. Okay, so that is nothing but we get it as 1 into 1 plus 2 into 2 plus 2 into 2. Next, first row with second column, 1 into 2, 2 into 1 plus 2 into minus 2. Next, first row with third column, 1 into minus 2 plus 2 into 2 plus 2 into minus 1. Next, second row with first column, 2 into 1 plus 1 into 2 plus or minus 2 into 2. Second row with second column, 2 into 2, 1 into 1 minus 2 into minus 2. Next, second row with third column, that is 2 into minus 2 plus 1 into 2 plus minus 2 into minus 1. Next, third row with first column, so minus 2 into 1 plus 2 into 2 minus 1 into 2. Next, third row with third column, so minus 2 into 2 plus 2 into 1 minus 1 into minus 2. Third row with third column, minus 2 into minus 2 plus 2 into 2 minus 1 into minus 1. Okay, so now this is equals to 1 by 3 into 1 by 3, it is 1 by 9 ma. So 1 by 9 is outside, 1 is a 1 plus 2 is a 4 plus 4 and 1 is a 2 plus 2 is a 2 and minus 2 is a 4, 1 is a minus 2, 5 is a 4 and here it is minus 2 and 2 is a 2, 1 is a 2 minus 2 is a 4, 2 is a 4 plus 1 is a 1 minus the minus plus 2 is a 4 and 2 times is 4 and 1 2 times 2 and minus plus 1 1 times is 2. So here minus 2 1 times 2 plus 2 times 4 minus 2 1 times 2 and here it is 4 plus 2 plus 2 and plus 4 plus 4 plus 1. Okay, this is equals to 1 by 9 into what we are going to get here. So 1 plus 4 plus 4 it is 9 and 4 minus 4 it is 0 and minus 4 plus 4 it is 0, 4 minus 4 is 0 and 4 plus 1 plus 4 is 9 and plus 4 minus 4 0 plus 4 minus 4 0 plus 4 minus 4 0, 4 plus 4 plus 1 is 9. Take 9 common, we can take 9 common, right? So 1 by 9 into, if you take 9 common, then we get it as 1 0 0 0 1 0 0 0 1. So 9 and 9 gets cancelled. 9 and 9 gets cancelled. So what is remaining here? Identity matrix. Identity matrix we can write it as I. Identity matrix we can write it as I. Is it equal to the required RHS? Yes. This is only the required RHS. Therefore, A into A transpose is equals to I. That is nothing but. Okay, so what we have to prove, what is asking, A inverse is equal to A transpose. Both are same only. Okay, A inverse is equals to A transpose. Hence proved. Okay, so here this is the required solution. If A is a non-singular matrix, then prove that A inverse is equals to adjoint A by dt. Okay, so we used this formula. So now we are going to prove the formula. Okay, so here in this problem, okay, A is a non-singular matrix, means the determinant is not equal to 0. Okay, let I am taking A is equals to, let I am taking A is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, so I am taking the matrix like this. Okay, after that, let the cofactors of A1, comma B1, comma C1, A2, B2, and so on are okay same but with the capital letters. Okay, so small a1 cofactor taking as capital A1, small b1 cofactor capital B1, small c1 cofactor capital C1, and small a2 cofactor capital A2, and small b2 cofactor is capital B2, and so on. Okay, therefore what is adjoint A? Then adjoint A is equals to same, but we have changed in the letters, that's it. Okay, A1, B1, C1, A2, B2, C2, A3, B3, C3, A3, B3, C3. Adjoint A is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3, and transpose of this. What is the formula for finding the adjoint A? Here, adjoint A is equals to cofactors of A whole transpose. Okay, so then what is adjoint A? Finally, we get the adjoint A as A1, B1, C1 is a first row, writing as a first column A1, B1, C1, and A2, B2, C2 is a second column, and A3, B3, C3 third row, writing as a third column. Okay, so now we multiply. Okay, so here so A into adjoint A, I am finding the product of A into adjoint A is equals to, so here A1, B1, C1, A2, B2, C2, A3, B3, C3, A3, B3, C3. Okay, multiplying with the cofactors. What are the cofactors? Capital A1, capital B1, capital C1, and A2, B2, C2. Okay, so columns A3, B3, C3. Okay, so now multiplying now. Here first matrix rows, we are multiplying with the second matrix columns. Okay, so that is nothing but, here we get it as small a1 into capital A1 plus small b1 into capital B1 plus small c1 into capital C1. First row with first column completed. Now first row with second column. A1 into capital A2 plus small b1 into capital B2, small c1 into capital C2. Next A1 into A3 plus small b1 capital B3 and small c1 capital C3. Okay, so similarly second row with first column, second row with second column, second row with third column. A2 into A1 plus B2 into B1 plus C2 into C1. A2 into A2 plus B2 into B2 plus C2 into C2. Next, A2 into A3 plus B2 into B3 plus C2 into C3. Next, A3 A1 B3 B1 C3 C1. Okay, third row with second column. Okay, A3 into A2 B3 into B2 C3 into C2. A3 A3 B3 into B3 and C3 into C3. C3 into C3. Okay, so here by applying properties of determinants, by applying properties of determinants, here the first one, whenever we have A1 and cofactor of A1, B1 cofactor of B1, C1 cofactor of C1, that is the value of det A. Others are 0. Others are 0. Here also first one is 0 and A2 cofactor of A2, B2 cofactor of B2, C2 cofactor of C2. This is the determinant of A equal to determinant of A. And what about the remaining? Remaining are 0 here. Okay. Even third row also, first two elements are different, they are 0. And A3, capital A3. So here this is also equal to det A. Okay, take det A common. Take det A common. Okay, so if you take det A common, det A is outside and 1 0 0 0 1 0 0 0 1 0 0 1. Okay, here A into adjoint A into adjoint A is equals to A into adjoint of A is equals to some det A into I, we are getting det A into I. Okay, so take that det A to this side, take the det A to this side. Okay, so A into adjoint A. Okay, here det A is multiplier. If you take it to this side, divides. If you take it to this side, divides. Is equals to I. Is equals to I. When we multiply the two matrices, then we are getting I. If the product of two matrices is equals to I, then one is inverse to each other. One is inverse of the other. Okay. Here, if you want, we can prove here. Okay. Similarly, okay, so we can prove it as adjoint A into A. Adjoint A into A is equals to same, we get det A into I. Okay. Here we know that A into B is equals to I. If AB is equals to I or BA is equals to I, then A is equals to B inverse. One is inverse to each other. A is equal to B inverse or B is equal to A inverse. B is equal to A inverse. If we apply the same thing here, okay, the product is equal to I. So A inverse is equals. Therefore, A inverse is equals to adjoint A divided by det A. Adjoint A by det A. Hence proved. Hence proved.